So I welcome everyone. So let's begin the topics. So as we discussed in the last topic, we have discussed some basic how the data has been transferred and data has been written back. Data has been read and data is right on the basic architecture using this diagram. And we also discussed how the read-write control signal works. So the in today's lecture we will discuss how the some of the topics regarding some of the terminologies regarding the memory. So first is memory access time and the memory cycle time. So these both are an important topic, memory access time and memory cycle time. So what is memory access time? Memory access time is the time difference between the initiation of an operation on the memory and the completion of an operation. So actually a memory access time is an the time on a single operation, not the different operations. Let There is an operation called a. So let a which is let be a read operation. So there is a read operation. I think this is not good. There is a read operation. So there will be an initiation from here, and as the time this is the time, okay, as the time goes, and at that point of time the read operation will be completed. So this time gap is taken as a memory cycle time. So memory access time. So the memory access time is the time difference between, time gap between the initiation of the operation to the completion of an operation. So we can also say it as a time between read and MFC signal. So as we know, to initiate a memory operation we need to call a read signal, and the memory operation completed when the MFC signal, that is memory function complete, that signal is been initiated, acknowledged. So the gap between these both can be read as a memory access time, and the same memory cycle time, that is a time delay between successive two memory operations. So let there is two I will erase it first. So let there will be a read operation and it is completed, then again a read operation and again a write operation. So this is the sequence, let it be. So the time difference between these two successive operations, whether it can be read and read, can be a read to write, anything maybe. So the time difference between a successive two memory operation is known as the time difference between this gap is known as memory cycle time. So what is memory cycle time? Memory cycle time is nothing. Memory cycle time is the time difference between the time difference between the two successive memory operation. That we can be a two read operation, two write operation, anything it can be, okay. So it depends on the implementation of memory unit, how it can be larger or it can be smaller. So that dependable. And so we are talking about memory units. The first thing we have to discuss is the RAM, random access memory. So as we all know what is RAM, I think. So the advantage of RAM is the data can be accessed and read, write or read, anything that is simply accessed from any location in a fixed time, okay. That's the advantage. So as we know, there is two type of okay, clear. So there's actually two type of memory operations. One is so I will just make a memory, let it be a memory. So I want to access data here. So this is all cells, memory cells. So what happens is there is two type of memory access. One is sequential access and there is another one is direct access. So what happens sequential access is that pointers will go through this. First it will point this and by this or jumping and finally it comes to the data where we required. So it will take lot of time. The disadvantage is the time dependability is on based on the location, okay. We can take an example of memory tapes, that CD or cassette that used in the older time, that begins to a sequence of data where the data position is a factor that depends on the time, okay. So where is the data, it depends the access time. If the data is so long, I mean so distant, it will take a long time to access the data. If the data is on here, it will be easily be sorted out. And another thing is direct access. So if we know the we can just directly jump to that specific location. There is no problem. Like the technology we uses here right now, hard disks and SSDs like all, and even RAM. This direct access, we can just at any time we can just jump to that specific cell or specific sector. The time taken for everything is same. Okay, it doesn't depends the data location. I mean the time taken is not dependable on the data location. Okay, that is what I am saying here. Let I want to access the data from the location of 0, location of 5, and location of 9. So the time taken for the function of accessing the data will be same. Okay, now this is just a equation I just wrote back. The time function for every equation will be same. That is what I said, in a fixed time. Okay, data can be accessed from any point in a fixed time. That is the advantage. So magnetic tapes, disks, everything that depends on the position of the data as I told. So that is sequential. The data should go through the cycles, then only that it can reach there. And here we can what is the advantage is it can be directly be accessed. That is the advantage of RAM. Okay, so okay, so the last topic in this region, the process of the computer is little more faster than the memory units. That's it's a general idea. And what happens is the processor of computer can usually process instruction and the data faster than fetched. As we all know, the processor actually do much more quicker operations than as a fetch or write back. So that make a standard version that let it be a processor. So so there's a processor here, and this is a memory unit, and this thing okay, so this thing do things very fast, like before the data is fetched and it go for the second thing, I mean second word, the data here will be processed. Okay, so there will be a star version here, like the processor to wait for a few minutes, or not for minutes, just for a second, milliseconds of time, even though the processor is taking a going to an ideal state. Okay, so that is what star rises here, like the processor has nothing to do for a while. So to resolve that, what we need is we can't slow down this processor. We can't like say okay, there is this star version, do one thing, slow down the processor. It can't be possible. Okay, we cannot slow down the processor. What we always need, we need a super fast processor or processing that do at a good speed. So we can't slow down the processor. What we can do is we can improve the speed of the memory unit. Okay, so we will improve the speed of memory unit. What will happen, so we will work here. Okay, we will improve the memory unit speed. So what happens in this scenario, we will explain. So here we are going another concept called as cache memory. So this is the cache. Okay, so the memory will not be fetched from like this. This is not this is not going to be happen. Now the memory will be like this. Okay, and this is connection and this is connection. This is cache. Okay, this is known as cache. CACHE. I think I should not write this like this. This is cache, and what happens is the memory is the processor the cache will hold the program and the data which is currently been executed, I mean regarding like that. And cache is super fast. Okay, cache is fast, and cache is also low memory. Okay, there is no very small size of memory, but even though it is small size, cache is super fast. So what happens is the memory processor doesn't needs to go for go for the memory and search the whole entire memory. The processor can easily come here, search a small memory itself, and it's also a fast memory, so it can do things very fast. Okay, the fast it can operate in a very fast memory. That and the processor the cache can intercommunicate with the memory and like swapping the data and all this thing. Just I will show the cache in the system. Like this is a task manager on a basic computer. So we go on for the disk performance, like memory. We can see there is I think should be there. Okay, so okay, so this is a CPU. So this is a CPU performance. Okay, we can see there is three cache here, L1 cache, L2 cache, and L3 cache. That is different type of cache. So L1 cache is 128 KB, and L2 is 1512 KB, and this L3 is 2 MB. So even though this is a small in size, it is a highly because it's the speed is very high. Okay, so that's all. So that's the method, like processor even the small and cast memory is large and vast. So communication will be like this. And the virtual memory is a type of memory that can increase the physical memory, okay, RAM, but it doesn't mean we are going to add some chip or something like that. Virtual memory is what we do is we will allocate the part of our second memory to the RAM itself, like let it be a primary memory, that's our RAM, and there is a secondary memory. So what happens is sometimes it is not enough. Okay, so sometimes it is not enough to hold some data. So what happens is we will partition some region of our primary memory, I mean secondary memory, do the duties of the primary memory. So what happens is some data will be stored here. Okay, some data will be stored here regarding the primary memory. So there will be a communication like this, so it will improve the performance. So that's all regarding the virtual memory. Even though it seems like increasing the RAM size, but it doesn't increase the RAM size by physically. It's a virtual memory. Okay, the RAM will be mapped to there, so it's the memory management. So this is the topics, and I think easy to understand. From the next videos we will begin with the semiconductor RAMs. It is a much more complex topics, I think. Okay, thank you.